Okay, so today's lessons or video is all about how efficient is a chemical reaction. So if you owned a factory, lovely factory, if you owned a factory and you were paying for each lorry load of reactants going in, and then it goes through the complicated factory equipment, and then you get a lorry load of products coming out, how can you judge how efficient your process is? And there are three. There's not three, because I've lost my little... Oh, here we go. Right, off to a good start. There are three ways of judging how efficient a chemical reaction is. So they are the percentage yield, the atom economy, and the rate. And we'll look at each of these in turn. So the percentage yield. What is the percentage yield? Well, percentage yield is pretty straightforward. The percentage yield is the actual yield divided by the theoretical yield times 100. And I've just explained something by using two other things that you don't know yet, but we'll get to that. So what is the actual yield? The actual yield is what you actually make. So the actual yield, what you actually end up with, how much product you actually get. So the actual yield, I shouldn't have really written it like that. The actual yield is how much product you end up with. So however much product you end up with, that is your actual yield, because it's the yield that you actually got. Clues in the name. So the actual yield, how much product you end up with, and the theoretical yield, and I've left myself absolutely loads of space for this one. So the theoretical yield is the maximum possible yield in theory. So in theory, as in, if absolutely every single last atom you put in reacted, every single last atom, and not only did they all react, but you also managed to get them all out of the beaker or the big container that you were doing it in. You didn't, not only did you not spill any, but you managed to get them all out at the very end, and they have absolutely all reacted down to the last atom. So that is the maximum you could have got in theory. So theoretical yield is the maximum that you could have got, potentially, and the actual yield is what you actually got. So as an example, it's just like working out percentages like you do in maths, right? So if we said Baxter takes a test, so Baxter scores... right, let's say 15. Baxter scores 15 out of 20. What's his percentage? Well, what do you do? So, well, he got 15, the score he got, divided by 20, which was the maximum possible score he could have got, and then you times it by 100 to turn it into a percentage. So 15 divided by 20 times by 100, 75%. What you did get divided by the maximum times by 100. And if you look back at the percentage yield, actual yield, what you did get, theoretical yield, the maximum. So what you got divided by the maximum times 100. So it's no different than working out percentages on a test that you would take in school. So as an example, like what would that look like in an actual science question? So let's get these out of the way. So Jafina reacts 12 grams of carbon to make carbon dioxide. Not sure why. She's trying to contribute to global warming, I guess. Don't tell Greta. Right, so Jafina reacts 12 grams of carbon to make carbon dioxide. She collects 22 grams of carbon dioxide. The theoretical yield was 44 grams. Calculate the percentage yield in Jafina's experiment. So if we go back to what we need, see if I can fit both of these in. There we go. So, actual yield divided by theoretical yield times 100. So the actual yield, what did Jeffina actually get? She managed to get 22 grams. So 22 divided by theoretical yield. What's the maximum she could have got? The maximum, so the theoretical yield was 44 grams. So 22 divided by 44. What a coincidence, these maths worked out nicely. Times by 100. So Jeffina's theoretical yield is 50%. And there's two types of theoretical yield questions. The first one looks really similar to this. So it's where they give you, rub these out to make some space. They give you the actual yield, they give you theoretical yield, they're asking you a percentage yield. Really nice, simple, straightforward. So let's say Franklin's reacting something. Franklin manages to make 16 grams of product. The maximum he could have made in theory was 40 grams. What's the theoretical yield? So actual yield 16, theoretical yield 40, because that was the maximum. 16 divided by 40 times 100. So 16 over 40 is 0.4. You can use a calculator in the exam, but 0.4 times 100, so 40%. So hopefully quite a quick, easy explanation. Yes, you have to remember this equation, but it's just working out a percentage. What did you get? Divided by what it was out of, times it by 100. Where it starts to get slightly more complicated is where they don't tell you the theoretical yield, and that's where you need to use some of your chemistry knowledge. So if you need to calculate the theoretical yield, so we'll go back to our Jeffina question, and I know we've already done this, you know it's 50%, but let's just say, for argument's sake, if I change the question and I'll take out that. So you guys already know that the theoretical yield is going to be 44 grams because I told you and then I've rubbed it out. But let's say they ask you to calculate the percentage yield and they haven't given you the theoretical yield. So what you need to do, first of all, we start with the balanced equation. So she's reacting carbon. So we've got carbon. She's reacting it with oxygen. They would give you this in the question. They wouldn't ask you to write the balanced equation and do this. So I'm doing it as we go. If this was an exam question, they would be giving you this balanced equation and asking you to apply it. But let's just do a bit of revision for the sake of it anyway. So carbon plus oxygen. So oxygen is O2. And we are making carbon dioxide. One carbon, two oxygens. So it's already balanced. So we don't need to do anything. So back to calculating the theoretical yield. So we know in the question, Jeffina had, and I've made these numbers nice and easy, Jeffina had 12 grams of that. But we want to know, in theory, if you had 12 grams of carbon, how much carbon dioxide could you make? So let's look at moles. There's no big number there. So if there's no big number, remember, scientists are lazy. No big number means basically there is a 1 there. No big number there, so basically there is a 1 there. So what we're saying is 1 mole of that would make 1 mole of that. So we go to moles. Moles equals mass over mr or AR. How much carbon do we have? We go back to our question. She had 12 grams of carbon. So the mass equals 12. What's the AR, MR carbon? So we look at our periodic table. I haven't got one of those to hand, unfortunately. So here's a little bit. So carbon, which one's the AR? It's the top one, it's a 12. So we've got 12 divided by 12 equals 1. So Jeffina is using 1 mole of carbon. I've done this to make the example nice and easy. If she's using 1 mole of carbon, well, the ratio is 1 to 1. So 1 mole of carbon would give you 1 mole of CO2. So we've got 1 mole of that, and our equation tells us we will have 1 mole of that. Why are we doing all this? We want to work out the theoretical yield. So now we're looking at carbon dioxide. We know that moles equals mass over mR, we know we've got 1 mole of it, because that's what we've just worked out. So we've got 1 mole equals, we don't know the mass, that's what we're trying to work out, divided by the mR. So carbon is that, oxygen is that, so it's CO2, so it's C plus O plus O, so it's 12 plus 16 plus 16, which equals 44. This is a bit of revision from an older topic, so if you need to work out relative molecular masses and things, there's other resources online, but hopefully you can follow. CO2, 12 plus 16 plus 16, so the MR is 44. So we go back to this one, so the MR is 44, so 1 equals something divided by 44, so we rearrange that, and you get moles times by mR equals mass. Moles we know was 1, and you go back, rewind the video if you want to see where that 1 came from, but it was 12 grams of carbon. We worked that out, that was 1 mole. This tells us the ratio is 1 to 1, so 1 mole of that would be 1 mole of that, which is where that comes from. The MR of CO2 is 44, so 1 times 44 equals 44 grams. So this has given us our theoretical yield. The maximum possible, if you start with 12 grams of that, the maximum possible yield you could get would be 44 grams. So then we go back to our question. Jeffina reacts 12 grams of carbon to make carbon dioxide. She collects 22 grams of carbon dioxide. So our percentage yield equals actual yield divided by theoretical yield times by 100. The question told us that... Okay, that was annoying. My phone ran out of storage, so cut the video off, and I didn't notice and spoke for about another 10 minutes. So just trying to get this back to where it was. So apologies if there was a bit of a jump in the video there. Right, I think, so I went back and watched the end before the recording just cut off. So we were at the point where we'd worked out the actual yield, we'd worked out the actual yield was in the question. Question says, actual yield, how much did she get? Jeffina got 22 grams of carbon dioxide. It doesn't give us a theoretical yield, but we worked it out. It was 44 grams, which for you was about 20 seconds ago, but for me was 10 minutes ago. So apologies if I'm a little bit lost here. So actual yield, 12 grams. Theoretical yield, I said 12. Actual yield, 22 grams. Theoretical yield, we worked it out to be 44. So it's 22 divided by 44 times by 100, which I haven't got space to squeeze in. So it's 50%. But you know that because we've already done that question. I think the easiest way of showing you, if I keep everything else about this question the same, and let's say, but what I will change is how much carbon she starts with. So let's say she starts with 18 grams of carbon. So they've asked us to work out the percentage yield, but they haven't given us the theoretical yield. They've given us what she started. They've told us she got 22 grams. We need to work out the percentage yield, which means we need to work out the theoretical yield. So I'll go back to this. It's one that it's the same equation that we've already done. Just get rid of our notes. So we had carbon plus oxygen goes to carbon dioxide. It's already balanced. The ratio is 1 to 1. We know, we know how much carbon we've got. We need to know if every single last bit of that reacted, how much carbon dioxide we can make. So the ratio of the moles is 1 to 1. So if we work out moles, it will let us do this. So we've got moles equals mass over AR. I wrote MR last time. MR for molecules. Sorry, MR for molecules, AR for atoms. This one's an atom, so I use AR. So the mass go to our question. How much did Jafina have? She had 18 grams of carbon. So 18 carbon, you look it up on the periodic table. The AR, it's on the periodic table, it's 12. 18 divided by 12 equals 1.5 moles. So 1.5 moles of carbon is what we put into the reaction. The ratio is 1 to 1. So if we put 1.5 moles of carbon in, we should get 1.5 moles of carbon dioxide out. We need to know the mass, not the moles. So we have mass equals moles times MR. How many moles of that have we got? We should have 1.5 because we've just worked that out. What's the MR of CO2? Skip back earlier in the video if you need to see it. It's 44. 12 plus 16 plus 16, 44. So 1.5 times 44 equals 66. So the theoretical yield is 66 grams. And my phone's running out of storage again, so I have to pause the video and delete some more apps. Okay, take 3. Right. After that app deleting frenzy, hopefully there's enough space left on my phone now. So, where are we up to? Because it's been 5 seconds for you. We just worked out 66 grams was the theoretical yield. So back to Jafina. She reacted 18 grams. She made 22. Calculate the percentage yield. How do we work out percentage yield? We need the actual yield divided by the theoretical yield times by 100. So the actual yield, that was in the question. Jafina managed to get 22 grams. So 22 grams was the actual yield. The theoretical yield, that was what we had to work out. It was 66 grams. So 66. 22 divided by 66 times 100. So we are looking at 33.3%. Hopefully that made sense and was a lot more the flow of that was a lot better for you than it was for me. Right. So going back to this. Okay. So judging the efficiency of chemical reactions, we've got the percentage yield, which you know how to work out. We've got the atom economy, which you don't know, and we've got the rate, which you don't know. This one actually took a lot longer, even ignoring the random video stops, than I thought. So I think I might save the next two for the following video. So what do you need to know about percentage yield? What is percentage yield? It's the percentage you got compared to what you thought you could have got, just like it would be in a test. What do you need to know it? What do you need to be able to do to know it? You need to know the actual yield, what you actually got. You need to know the theoretical yield. In theory, what is the maximum you could have got? And then you work it out from there. I'll do one more example on percentage yield. If I can find my pen. Right. So, Nigel burns 8 grams of hydrogen, H2. He collects, just try and work this out to make the numbers easy. I'll go with 36. Let's see if that works. He collects 36 grams of H2O. I know it's been a while since we had a lesson, but H2O, that is water. So he burns 8 grams of hydrogen. He collects 36 grams of H2O. What is the percentage yield? So what's the percentage yield? So we need to know, so the percentage yield equals actual divided by theoretical times 100. We know the actual yield. It says in the question he managed to get 36 grams. So before we can do the rest, we need to know what the theoretical yield is. That's got something like that already. so's that. Right, here's a rubber. So let's do our equation. So hydrogen, H2, plus oxygen, O2, goes to water, H2O. Let's balance it. We've got two of those, two oxygens on this side, only one over there. So we'll put big 2. So now we've got two oxygens. 2 lots of 2 is 4. We've only got 2, so we need to do that. So that is our balanced equation. They would give you that. I'm just doing it for revision, yeah? In this question, they can ask you to balance things, of course, but if it's a question about percentage yield, they're not going to be asking you to balance the question as part of, balance the equation as part of that. So we needed to know, if we look at this, it's a nice ratio. It's 2 moles to 2 moles. So if we work out how many moles we have of this, we can work out how many moles we were supposed to have of this. So if you've got to remember, moles equals mass divided by mR. So let's look at H2, the mass. Let's go back to what Nigel had. Nigel burns 8 grams of H2. So the mass he has is 8 grams. 8 grams. What is the mR of H2? Need a periodic table. H is 1, 1. So the mass of a hydrogen atom is 1, but it's H2. So the hydrogen atom, because it goes around in pairs, remember, H2, H. That is 1 plus 1, so it's 2. So 8 divided by 2 equals 4. So we have 4 moles of H2. Let's look at our equation. 2 to 2. What is that telling us? 2 moles of that makes 2 moles of that. So the ratio is 1 to 1, because obviously 2 to 2 simplifies to make 1 to 1. So however much of that you've got, you make the same amount. So if we've got 4 moles of H2, we will make 4 moles of H2O. So now we need to know, so we know if we put 4 moles of that in, we are going to get 4 moles of that out. We need to know the mass of that. So you've got moles equals mass divided by mR. You can rearrange that and it makes moles times mR equals mass. Moles was 4 because we've just worked it out. The mR of H2O, again, periodic table, 1, 1, H, 8, 16, O. So we've got 2 lots of 1. 1 plus 1 is 2, plus 16 is 18. So we've got 4 times 18. So 4 times 18, I believe, is 72. So we've got 72 grams. So the maximum theoretical yield is 72 grams. So going back to our question, we wanted to know the percentage yield. So we need to know the actual divided by the theoretical yield, and then we times it by 100. Going back to our question, Nigel burned 8 grams. So we know Nigel burnt 8 grams, but he got 36. 36 grams was the actual yield. So we've got 36 divided by, what's the theoretical yield? Well, we just worked that out. It was 72 grams. So 36 divided by 72 times 100 equals 50%. So how efficient is chemical reaction? How do you know percentage yield? You can do it the nice easy way where they will be really kind and give you the percentage yield. They'll give you the actual and the theoretical. Or there's a slightly more involved question where they give you the actual yield, but you have to work out the theoretical yield. Hopefully that's made sense. If it hasn't, watch the video again. Have an average week.